Welcome back, Hawaiian Shirt Coder here again, and we continue on with our Web API series. In the previous video we hooked up our data access layer using one approach. Now I'm going to use a more preferred approach for hooking up our data access layer. Stay tuned. So in the last video we finally managed to hook up our SQL database using our data access layer, and we did that via what I called approach 1, which was to call the data access layer directly in the controller. In this video we're going to have a look at a second approach, and this second approach is my preferred approach. So we're going to call our data access layer, but we're going to call it via a new layer that we haven't created yet called the business logic layer, or in this video you'll see me sometimes refer to it as the BLL. So let's have a look. So here's our current design, and this is what we did in the last video. We basically finally hooked up our SQL database with our data access layer, and we called it from within our controller. And in our example we called it from our fixtures controller. So the fixtures controller no longer uses the in-memory database. Instead it is making calls to our data access layer, which in turn is requesting queries or commands from the SQL database in order to fulfill the API request. Now this approach is fine and it does work, and depending on what your API does, is perfectly acceptable. If you've got an API that is purely a CRUD API, it is literally returning data and posting data, deleting data and updating data from your database, this approach will work fine. But quite often web APIs have a layer of business logic where there may be some pre-processing, some post-processing, some mapping or some other stuff that happens in between the request coming in and getting issued at the database. So another layer is required for these more complex web APIs. Call the DAL from the business logic layer, approach 2. So these are the learning outcomes that we're going to try and work through in this video. Like I've said already, this is my preferred approach, especially when there is domain logic required in your web API. It's not purely a CRUD based web API. It adds to our single responsibility principle. So we've got a class that does one particular thing and that's all it does. So we've done this already with our data access layer. Our data access layer class has one responsibility, and that is to issue queries and commands at the database. Our business logic layer will have one responsibility, and that will be to handle any particular business logic or domain logic that our web API needs to perform, be that pre-logic or post-logic or any other sort of logic. By adding this extra layer of abstraction into our underlying architecture, it makes our API more open to future change. So nothing is coupled. Again, we've got a loose coupling going on, and we can swap various layers of our underlying web API in and out as we see fit. By the time we've finished this video, the controller will know nothing about the underlying storage. So the sports management system web API controllers won't know anything about what data provider is used for getting the data, where the data lives, if it's a hard-coded list, if it comes from a file, if it comes from a SQL database, if it comes from a NoSQL database. It won't care. It just knows a thing it can delegate a request to, which will be our business logic layer that says go and get me a player. And how it does it in the background, it doesn't care, it just awaits a response that comes back to it. So another outcome from using a business logic layer is different logic can be used for different use cases. So we may have a business logic layer that is purely for the administrator of the system that can do different things and apply different logic and get different views of the data to, say, a public access user of the system. So for example, you wouldn't expect that a public access user would have the permission, for example, to go deleting fixtures out of the system. That's just an admin task. So it gives you the opportunity to splice and dice these sort of domain logic as you see fit, so that you can have multiple different types of business logic layer. In the example we're going to do, we're probably going to have it all just in one, just to give you a demonstration and an overview of how it works. And finally, once this is all done, we'll end up with a slim controller. In the early videos we had a very fat controller that was doing everything. It needed to know about the database, it needed to know about the mapping, it needed to know about the queries to get it the data, it needed to know about the routing of the requests to the methods. By adding the data access layer and calling that directly, that's got a little bit better, and by adding the business logic layer, that will get even better. So the slimline controller's only responsibility will be to route requests from the user to methods in the controller, and then it will delegate the responsibility of any business logic to the business logic layer, which in turn will delegate getting the data from the persistence layer. So this is what our proposed new design will be after we finish this video, and the improvement is to add this new area that is in green called the business logic layer, or BLL. And once we have this in place, it will just be the BLL that will call the data access layer. It will no longer be the controller. So the controller won't know anything really about how it accesses data. All the controller will be able to do is contact the business logic layer to make a request. The business logic layer in turn will contact the data access layer, which in turn will contact the underlying database. So as you can see, we have a nice separation of concerns. We have routing controlled by the controllers, domain-based logic, if there is any, controlled by the business logic layer, underlying persistence of data controlled by the data access layer, and the database provider that we've selected. And just to finish up, I thought I'd provide a different view of the same sort of diagram really. So if you've been following along throughout this series on Web API, you will know that in our early videos this was the sort of flow that we had. We had an outside client, which in our case our outside client at the moment is the Swagger page, that makes a request for some sort of sports management data that hits our Web API. The Web API controller method has all the logic in it, so it knows about the database, it knows about any data transfers that it needs to do, it knows how to run the query, and it knows the route as well. And all of that happens in the controller method. So they are extra large or fat controllers that are making the route from client through the business logic to the database and back. Then in the last video, video 9, if we move into the middle section of the slide, we introduced a data access layer and we actually wired it up. So now the flow through the system is the client makes a request to the controller routes the request to a method, inside itself, and that method knows something, or it delegates responsibility for talking to the database to the data access layer. Then the data access layer issues a query to the database and then flows the message all the way back to the client. So we've introduced a separation of concern by introducing a DAL level that gets called by the controller. So in this video, what will happen is we add an extra layer of separation, which is the BLL. So the flow this time will be the client will make a request, that will hit the controller. The controller's only job now is to route the URL request to a method. Inside that method, the method will know of the dependency that is the business logic layer. So it will pass the request off to the business logic layer, which will go and do any post mapping, any sort of business logic it needs, or it may not even have any business logic if it is a pure CRUD. And in turn, that will pass the request through to the data access layer, which will go and get or manipulate the underlying data that it needs from the database. And in turn, all that request will flow back up through the levels to the controller back to the client. So in this final video, basically the controller will know about the business logic layer, and the business logic layer will know about the DAL, and the DAL will know about the database. We won't be able to do things like the controller won't be able to directly talk to the database. The business logic layer can't talk directly to the database, and the client can't talk directly to the database. So we've got a nice separation of concerns. And by having this separation of concerns going forward, we can test each of these layers independently of one another in both unit tests and then further down the line in integration tests. So the first step in starting to implement approach 2, introducing a business logic layer, is to just do a couple of spot checks from where we left off in the previous video, and one of them is that we still have our connection string in our app settings file, which resides in sms.api. We'll still need that, and also once we introduce our business logic layer, we will be going back into program.cs and we will be adding a new service. We're going to wire in the business logic service via dependency injection in a similar way to how we did the data access layer. So that's the first thing we need to do. All those things are in place, so that is good. So the next stage is to actually go into our shared library, and this is where we're going to start adding new code. For this demonstration, I'm not going to implement every piece of shared logic because that will involve quite a few bits and it will become just repeating the same thing really. So I'm going to give you a flavour of how that works. Then in between videos I will go away and actually do all the other mopping up of hooking everything up, both fixtures, players and availability. For the demonstration, in the previous video we altered the fixtures controller so it made direct calls to the API. Apologies, not the API, the data access layer. In this video we will be working with the player controller, which at the moment is still using the in-memory database, and we're going to wire this one up in a different way. So the player's controller will have the business logic layer injected into it via the constructor, and all our methods will use the business logic layer as the one thing that it knows about and it can talk to. In turn, the business logic layer will make the call to the data access layer. So that's where the data access layer will get wired in this video. So only the business logic layer, like we showed in the diagram earlier on, will know how to make a call to the data access layer. That may seem all a little bit confusing, but hopefully once we get started it will make more sense. Okay, so let's start building a business logic layer. So once we've done all of that, we'll be able to hook, like I said before, the controller to the business logic layer and the business logic layer to the data access layer. So then we've got this complete sort of cascade through all the various tiers to achieve what we want. So first of all, we go to SMS share. We go to the logic folder, which to start with I'm going to rename because I've been referring to the business logic layer as the BLL, so I'm going to call the folder BLL. So that's the first change we've made, and then I'm going to right click, add a new class, and this is going to be our concrete implementation of our business logic layer. So like I said before, you could have several classes here. Depends how you want to split your domain logic up. You could have it by users, so you could have a business logic layer that is specific to an admin role, whereas you could have another business logic that is specific to a user role. Just for demonstration purposes, I'm just going to have one business logic implementation, and I'm going to call this SMS logic. So all our domain logic resides in here. So let's go add. We'll change the namespace. We'll change this to public. And then we'll start building out our business logic layer. Now, our business logic layer how I've done it, we're going to have this one big sort of super class. We'll have things that is logic to do with players. It will have logic to do with fixtures. And it'll have logic to do with availability. But like I said, that will take too long to do all of this just in this demonstration. I will come back and backfill all of this so it is complete for GitHub. But for this demonstration, we're going to just do a few things to do with the player. So the first thing we need to do is we need to create a couple of private fields. So let's do this: private read only. And what we want is, like I said earlier, the business logic layer is the only thing that can talk to the data access layer. So one of the things that the business logic layer needs a dependency to is the data access layer. So this is what we're going to put here. We're going to say I data access equals data access. So that's similar to what we did in the previous video with the controller. When the controller was the thing that needed to know about the data access logic, all we've done is move it down a tier at this stage. So that's fine. The other thing I'm going to do is I'm going to also bring in another field for another dependency, and like we did in the previous video, this is for configuration. So we're also pushing the configuration down into the business logic layer as well. So basically the only configuration at the moment we need is to be able to go off and read the app settings file to obtain the connection string. So again, the controller, once this is complete, won't need to know how to contact a database. It won't even know that we're using a database. But the business logic layer will need to know how to go and get that connection string in order to call the data access layer with the connection string parameter. So that is good. And as before, we are also going to need a read-only property that is a string, that is the actual connection string. typed all this out again. In essence, I could have gone over to what we did in the previous video, the fixtures, and lifted those 3 lines out because they are exactly the same at this stage. And based on that, I am going to lift these out because the constructor is going to be exactly the same. So let's go back to the SMS logic and create a constructor. So CTOR double tab is the snippet to do that. Let's just paste those values in. So this is where we are wiring up our dependencies. So iData access is data access. And iConfiguration is config. There we go, so that's all wired up, and this will go away and get our connection string from our app settings. So that's all good, nothing really different at this stage to what we have done in the previous video. And now what we will do is we will create a method for the player that is some business logic. So what I'm going to do at this stage is I'm going to have the business logic method that gets a list of player summaries. So in essence, this maps very closely to what we've got in the data access layer for going off and getting all players, basically select star from all players, and then we're reshaping it into a DTO. So basically we're going to write a method in our logic layer that will help us fulfill this get action. It looks like this at the moment. So at the moment this method knows about the database because it's not even using the data access layer, and it also has to do some logic to convert the player into a player summary. So let's go and implement that one. So again, I'm going to be using asynchronous methods because the data access layer uses asynchronous methods, and this has a cascade effect on anything that calls it. So our business logic layer will need to be asynchronous, and in turn our controller will turn asynchronous. At the moment for player, this is still synchronous, whereas when we were doing the fixture updates in the previous video, we turned it to asynchronous, but we'll step through that bit by bit. So back in here, let's close that one so I don't keep opening it. Let's create a new method. So I'm going to copy and paste this to save a little bit of time and then walk through what the code does. So we've got a business logic method called getPlayersSummary. And what this does is this is asynchronous because it's got the async keyword, and that will mean it will return a task, and the task will be an enumerable, a list of player summary DTOs. Player summary DTO is our data transfer object that has this cut down lightweight set of data. Full name is active player and an ID. So something you would probably see on an opening screen just to list all the players. So that's what this is doing. Then the first thing we do is very similar to what we did in our fixtures controller, is we create a SQL statement that will get issued at the database. So this is the SQL select star from the player table. So that will return all the players when this statement is fired at the database. And then what we do is we make a call to our data access layer, which I've mistyped there. It's not called DAL, it's called this. So we say data access, and as soon as we hit dot, we get the options that are available. We can execute a command, or we can run a query, and run a query is the one we need whenever we're using a select statement. And we're going to say that we're expecting to get a player summary DTO shape of data back, and we pass in dynamic should we have any properties that or parameters that need to go with this SQL statement. In this case we haven't got any. And then we make the actual call and we say SQL statement new, which is the list of parameters because we haven't got any, and then we pass the actual connection string that we retrieved in the constructor. So it works exactly the same as it did in the fixtures one. It's just we've moved it a level down, like I said. But another thing this will do is we can now move this projection logic out of the controller, so it doesn't need to know how to perform a mapping, which means in turn it needs to know about players and player DTOs. So we can move this out and move it actually into our logic layer. So for this example, the logic that we're applying is the mapping from player to player summary DTO. A little bit of a contrived piece of business logic in this example, but it shows what that layer gives us, that added value and extra flexibility of things that we can do. So back to the logic. So rather than returning results, which at the moment is a list of player, that's actually wrong there, that should be player. And let's call this players. So from the database query we get a list of players back, and then what we want to do is shape that data. So here's our data access call. Then after that we're doing some post processing, which is in this particular instance mapping from player objects to player summary DTO objects. So let's do that. So what we will say here is var summaries equals from p in players select new player summary DTO, and then we'll just do the mapping that we've already got. So I could probably lift that from the controller, so we just do this just to save a bit of time again, and we paste that into here. We also need to wrap this in a couple of brackets and say return to list. And rather than return results, we return the summaries back. And that is an example of adding some business logic. So in this case we did some post-processing where we changed the shape. We could, in our business logic, we could do anything. There could be some pre-processing that happens here. Anything could happen in between. At some point we need to go and get the data from storage, which is the data access call. So that's an example. Let's try and wire this all the way up through to the controller. So in order to do this, we've got a couple of steps we need to do. At the moment we'll say that our SMS logic just purely has this one method in. We can add some more in a minute just to demonstrate maybe some updates and delete based logic, or maybe even a new contrived service. That's probably a better example. We might do that in a minute. So what we need to do now is, like we always say, we don't program against a concrete class, because whatever needs to consume SMS logic, we need to inject it. So we don't want in the thing that consumes SMS logic, which will be our player controller, to see var SMS logic equals new SMS logic. Whenever you see new, it should raise alarm bells. So what we need to do is we need to program against an interface. So the easiest way to do that is to convert this into an interface using the quick refactors. Right click, quick actions and refactors. Press that one, extract interface, and by default an interface always starts with an I, so it's going to create an interface called SMS logic. If we go to our BLL folder, you'll see now we have a new file that is SMS logic. If we open that up, here is the contract that is created in the interface. It says at the moment that anything that implements this interface needs to implement this method, a method called getSummaries, that will return a list of player summary DTOs. So that's created our interface. What we need to do now is wire it up into our web API. So let's go and do that. So we go to program.cs, and on line 20 we're going to add in a new dependency that will get wired up as soon as the web API gets bootstrapped and loaded up. So again, we do builder.services.add scoped, and we say SMS logic, which doesn't know what that is at the moment, so we probably need to bring in a using statement, use SMS shared logic, and then we say we want to use SMS logic, and I've got the wrong brackets around this. These should be angled brackets. So just to walk through this again, not going into great depths about how dependency injection works, but just so you get a gist, what this is saying when we wire up is whenever anywhere in the code you see a request to use an SMS logic, please create me an SMS logic, which is the concrete implementation that we've got. Again, like with the Dapper access, there could be lots of different ones that we can swap out depending on different use cases. But that's wired that up. So now let's just do a quick build just to check things build. So that's all good. So now we're in a position that we can go over to our controller. So let's go to the player's controller, and we're going to update this getData method. And I'm going to probably rename this getPlayerSummary. GetPlayersSummary. Let's call it the same as the actual method in our business logic layer, so you can see that they map one to one. So the first thing I'm going to do is I'm going to comment out the existing in-memory implementation. The next thing I'm going to do is ensure that this method is asynchronous. So you do that with async, and then we need to say task angle bracket action result, because we're interested in still returning all the HTTP goodness. So we want to return HTTP states codes, 200, 400s, 500s, whatever they are, along with the actual data. So that's made that asynchronous. The next thing we need to do is create a constructor for our player controller. So we do CTOR tab, and this constructor will need to inject in the things it depends on, and the things it depends on is just the business logic layer. So in here we will go SMS logic equals business logic, and then what we will do is we will right click and we will create a field, and we will stick to my naming convention of underscore and my convention of underscore. So just to reiterate what this does, when the web API gets fired up, the program CS will kick into life and it will go through wiring up all the services it needs. It will now, based on what we've just done, wire up SMS logic, so whenever a request is made for that, so for example in the player's controller there's a request for it here, it will say replace this and instead use this SMS logic concrete implementation. So that's all wired up, ready to use, and now we can actually go and fill in the implementation detail here. And the key thing that you'll notice is this is going to be a lot smaller, because all this is interested in doing now, the controller is routing to the correct action when someone does a URL request, and then delegating the responsibility of going and getting the data to the business logic layer, which in turn under the hood is going and doing some logic and also then talking to the data access layer, and then maybe doing some more logic and then returning that request back up to the controller. So let's do this. So I'm going to wrap the call in a try catch, just so we can see if anything goes wrong. And what we do here is we say return, let's do our summary equals await underscore business logic dot, and we see all the methods that are available from the business logic layer, and at the moment we've only implemented one, and that is get players summary, open close brackets, and then we can just say return okay summary. And in fact, we don't even need all of this code. We could make this purely a one-liner and just do this. And here we could do something else. At the moment I'm not going to fill this in. If something has gone wrong here, what we would do is we would do some login, which we haven't got to yet, and we would throw a user-friendly message back to the caller. It's probably, if we're hitting an exception, we're getting a 500 error, which is an internal server error of some sort. Can't speak to the database, lost connectivity, or bad gateway, something like that, but we're not really interested in that for this example. So what I'm going to do is just put a breakpoint on here, run through the example just to see if it actually works. So again, let's just do a quick build, and let's run it up. And we go down to the player one, and we are calling this API. So let's go try out, let's go execute. The URL has been routed to our player controller and to the get players summary endpoint. It knows it's an HTTP get, and it's hit our breakpoint. So then if we go press F11, we can step all the way through the tiers now and see what's happening. So first thing, it's going to call the business logic tier with and go to this method. So let's press that. All of a sudden we are in the SMS logic.cs, the concrete implementation. So that has also proved the point that this dependency injection has worked. We haven't had to use a new word value in our declaration. It's all been done by the dependency injection container, so that's good. So we can carry on with F11. So inside SMS logic, the first thing it's doing is building up our SQL statement that we need. Or hit that one. We are now back in our SMS logic layer, and if we have a look at the player, we now have a list of players that's come back from the database, which is great, and they're in the player shape. The only thing that needs to be done now by the business logic layer is some post-processing on that data to convert it from a players list into a player summary DTO list. So we hit F10 on line 31, controller. So we've hooked up our first controller using a business logic layer, and you can see that it's really made a big impression on our controller. In essence, if I get rid of this try catch stuff that we're not really using at the moment, the controller is literally one line, the action result. So that's good. So, and this one gave a demonstration of a bit of contrived logic where at the end we were doing a projection from a player to a player summary DTO. So it was some post-processing logic. I thought it'd be quite good to do another example, follows the same lines, but this time we're going to do some logic before we actually talk to the data access layer. So a good example that we can do for this, just to give you a flavour of how this works, is this endpoint in the controller where we want to actually add in a new player. So again, I'm going to comment out this code for the time being, and we're going to go into our SMS logic in our shared folder, and I've already started creating an extra method. So this was our last logic method. Let's close that one up out of the way. I've added this new one called save player. Again, it's asynchronous and it's passing in an add player DTO object, which looks like this. So it's basically very similar to a player object. The main thing it hasn't got is the ID field. So let's just go back a step again, and what we're doing when we come in here is, first of all, we are issuing or creating the SQL statement that we want to pass to the data access layer, and then we're calling the execute a command in the data access layer, which is called data access, not DAL. So now we want to do a bit of pre-processing before we actually pass that to the data access layer. So this is a pre-processing example. And again, it's slightly contrived, but it's to give you a flavour of what the business logic layer could do. So what we need to do is we need to map from an add player DTO to a player. That's basically the bit of contrived logic we're going to do here. So we're going to say var player equals a new player, and we're going to say that the email address equals the player to save email address, the first name equals the player just saves first name, the last name's exactly the same, the phone number, and the is active, and that's it. So all this is doing again is a mapping. It's not very exciting business logic. The business logic is irrelevant really. It could be any business logic. It's just for our particular example, I haven't got anything that's very complicated business logic, and it would deflect away from the purpose of the tier really. So all I'm doing is a mapping again. So we're creating a new player and we're mapping all the add player DTO mappings into there. And like I've said before, with mappings, I'm doing it object to object, hard coding it. There are third-party packages such as AutoMapper that could do this for you, that would make this even less code. So this is our pre-processing logic, and then what we're going to do is we're going to pass the actual player, because it's been transformed into a player now, as parameters into our data access call. So where we have our SQL statement, then on the next parameter is the actual parameters that the SQL statement requires, which is all of these. And then again the connection string, which has got collected from the app settings file in the constructor here with this call. So that's good. So we'll put breakpoint on there, and then we will actually go back to the controller and call this. So we've commented out all the code, and again we would probably wrap this in a try catch just in case it didn't work, because the execute a command in the data access layer doesn't return anything. So again, we could handle that in here with a bit of extra logic, having a try catch or something in here that would, if it's okay, it would return true. If it's false, it wouldn't. We won't bother with that for now. We'll just let this run through. What we will do is we'll just put try catch in here, and all we will say is await underscore business logic dot, and you will notice that it's not showing up our new method, and that is because I've missed a step. So if you go back to the concrete implementation of the logic, what we need to do is we need to copy this, because don't forget, we are not programming against a concrete implementation, we are programming against an interface. And if we look at our interface currently doesn't know about this new method we've just created. So if I just pop this line in here and finish with a semicolon, go save. Now go back to our player controller, and when I hit dot this time, we get save player. And we pass in the DTO that's come in the request. So this is the JSON that's come across the wire to us. And we just do that. And then we do a return no content. There we go. So we now got the ability to add a player into the system using our new business logic layer. And again, this has made the controller's method very thin. If you ignore the try catch error handling parts, it is literally 2 lines of code. So let's just try this out. And we have a build error. And what is our build error? The return type of async must be void. Yes, again, it's because I've missed a part out. All async methods must have a task. So a task of action result. So again, this will return back all the HTTP goodness. So that's all that's missing there. So if we just run this up again, and Swagger will pop up, And if we go down to our player, we should now be able to add a player into the system. So let's go to post. Let's try out. Let's just fill these in with some information. Let's pick Bertie Bassett. We'll leave the email as it is. We'll just put in a made up number again. And we'll say he's an active player, and we will hit execute. That hits our player controller, which hits the correct route, the HTTP post route. And now all this controller, all it needs to do, it's done its one job, which is basically hit the right action result. And now it's going to delegate responsibility off to the business logic layer. So let's just do that. Hits our business logic layer, which again has got created by our dependency injection. And it's going to hopefully jump into there. So here we are in our business logic layer. Hit our saved player. We're passing in a add player DTO that has all the fields we need apart from the ID, which is a system generated field. Comes into here, does our mapping, so all of a sudden, through those, which that's do, all of a sudden now we have a player object, which is of type player rather than of type add player DTO, and they're all mapped across, which in essence are exactly the same for our example. Then we're going to build up our SQL state, come in, we create our connects, and then comes back to the player controller level. We haven't had any sort of error, so we haven't jumped into the exception. And the last thing the controller needs to do, its responsibility, is to return back the suitable HTTP status code, which is a no content. So if we go F5, come down, we get a 204 success, no content, and the final thing is just to check the database. So we should have Bertie Bassett in the player database. If we just view the data, go over to here and do a refresh, there we go. So that's all working perfectly. So in this final demonstration of using the business logic layer, I'm going to create one more method. This time I'm not going to type the code out, I'm just going to walk you through what I've added. So this is an example of repurposing an existing query to do something else and letting the business logic layer filter it further. So I've created this new method in our SMS logic called getPlayersByStatus. And in the player model, you can see we've got this field here. It enables us to toggle a player on and off. So they're either active, so they're available to play in matches, or they're currently a member of the club but not available to play in matches, so they are inactive. So for example, in your sports club, you could be a non-playing member, and that would give you the status of is active player false. So if we go back to our logic, let's open this up and explain what it does. So we have no query in our database anywhere that says select star from players where is active equals true or is active equals false, but we don't really need one. We can repurpose a query that we've got somewhere else in our business logic, and that query lives in the method above, getPlayersBySummary. So if we open this one out, we can repurpose this query, return the list back, and then in the actual method perform some additional logic on that data set. So that's exactly what we're doing. So the first thing is we go and call the method above, getPlayersSummary. That returns us a list of player summary DTOs. And then what we do is on that list that we've got in memory, we apply an additional link filter with a where clause and say where is active player equals is active player, which is the variable we passed in. So that's either true or false, and then return the list. So I've added that in there, and because we program against an interface rather than a concrete implementation, I have lifted this method signature, copied it into the clipboard, gone into SMS logic and pasted it into there. So the final step, just to show this particular demonstration, is I've gone into the player controller and I've added a brand new endpoint, and I've called this endpoint get players by status. It is still a HTTP GET, and it has the route of is active player, and it must be of type true or false. If we don't put this little bit in here, when we come to run it, we'll get a conflict because it will look very similar to the method signature we've got here, expecting one parameter even though they're of a different type. So we're specifying the types to make this unique. And all this is doing is you're passing in from the client a true or false. It's running our business logic that we've just shown you, which in turn is making a subcall within itself to the other method, which is going off to the data access layer to get the information and then bubbling the results all the way back to the controller. So we'll just try this out very quickly. And you can see if we scroll down in the players list, we have a new endpoint, API/player is active player. Open that out, try out. It's expecting a parameter that is either true or false. If we go true, hit execute, we can see that it is going to call our business logic layer. Here's our new method. Our new method is going to call an existing method and return back some data. And then once it's returned back that data, just hit F5, we will see that there are 6 records in the database, but only 4 of them are active players with the word true in there. We can prove that by flicking this to false, running it again, just hitting F5, and this time we only get 2 back that have an is active status of false. So just another example of how we can write some business logic that can interact with our data that has got retrieved by our data access layer. So I'm the Hawaiian shirt coder. That's the end of this session. Please remember to like, subscribe, share with your friends. Remember, keep learning, keep exploring, keep developing, and I'll see you next time.